Hi. In this section, what we're going to do is we are going to run diagnostics on our merge. So if you'll remember in the previous videos, we went over pulling both the Gleditch and the polity data from the web, renaming the country code and year identifiers so that they're identical across the two data sets, cleaning up the polity data to deal with missing values, and then merging the two data sets. So what we're trying to do now is figure out how successful was our merge. So what I'd like you to do first is, if you haven't already, download the do file from Elms and run all the code except for the last command. Okay, once that's done, if we look over to the variable menu, you'll see that we have both the polity and the Gleditch data as well. And if we go to the data viewer, we see, of course, that we have country code and year, the identifier on which we did the merge, and then we have the polity data, the Gleditch data, but we also have this variable at the end called merge that wasn't included in either of the data sets. And the merge variable just has variables, just has numerical values between 1 and 3. Now this obviously wasn't in either of the data sets, but what it is a product of the merge. When we do the merge, Stata creates a new variable to tell us for each observation whether or not it was successfully merged. And if it is successfully merged, meaning that for that country year, so let's say USA 1816, there was data for both the polity data and the Gleditch data, that's given a 3. If it is just found in the master data set, that's given a 1. And if it's just found in the using data set, that's given a 2. So how do we get a sense for the distribution of the values of this variable? Obviously, we would just do a quick tabulation. So what we want is we first want to look and see how many of our observations got a value of 3. This is good. We see that 90% of our observations almost had data for both data sets. So those are observations for which the merge was successful, meaning that for that country year, USA 1816, United Kingdom 1913, and so forth, we had a polity score, and we also had population data from Gleditch. And then we go to 1 and 2 with 3% and 7% of the observations respectively. That means those are country years that were only in the Gleditch data or only in the polity data, only in one of the two data sets. Now why is that? Sometimes data sets have different temporal ranges, meaning they don't cover the same years. So that's the year component of country year. In other cases, certain countries may be in some data sets but not in others. Often this is the case with microstates like Monaco and some of the Caribbean countries that aren't covered in all data sets. To get a sense for what countries are going to be included in your data sets, you need to know what their selection rules are, and that's another reason to spend some time with the code books for these data sets. But for the time being, it's just important to know which observations were successfully merged, and we see 90% were. So that means when we run regressions that contain both population and polity score, for example, these observations will be used, and observations that were coded as 1 or 2 will be dropped from the analysis. So that's it for now. So what we've done in this module is pulled 2 data sets from the internet. We've cleaned up the data sets, prepared them to do a merge by making sure that the unique identifier, in this case country year, is named the same way in both data sets. We've cleaned up the missing values in the polity data. We've merged the two, and then we've done a quick diagnostic to see how successful our merge was. To learn more, I not only encourage you to take a look at the code books for these 2 data sets, but also to use the help command for the different Stata commands we used here. And you do that just by typing help and then the command. So for example, if you type help merge, you get a sense for the merge command and its different options. We'll cover more advanced merges in a later video, but for now,